Hey everyone, it's Mrs. Brimlow. Today we're going to talk about the converse of the Pythagorean theorem. You can click for a copy of the notes or you can just follow along with the video and get a copy when you return. So the converse of the Pythagorean theorem states that if a triangle has side lengths A, B, and C, and it works for the formula a squared plus b squared equals c squared, then the triangle is a right triangle. So basically, it's a way of taking three side lengths and proving whether the triangle is right or not. And how do we know it's a right triangle? We know this because the Pythagorean theorem only works for right triangles. It doesn't work for any other type. So we're going to go ahead and actually start with with the try it. Okay. So I'm a visual person, so I'm going to actually draw out a little triangle since they didn't give us one, okay? So here's my right angle, and I'm going to go ahead and fill it in. So triangle has side lengths 4, 5, and 7. So those are the three sides. Now, how do I know how to label the triangle? Well, I know that the side across from my right angle is always the longest side by hypotenuse. So this would be 7. And then 4 and 5 doesn't really matter because they're both legs. So with that in mind, 4 squared plus 5 squared equals 7 squared. That's what we're going to check. So 4 squared is 16, 5 squared is 25, and 7 squared is 49. So now I need to check, is 16 plus 25 equal to 49? And the answer to that is no, because this equals 41. So does a squared plus b squared equal c squared? No. Then what does that mean? Could these three lengths form a triangle? They could, but do they form a right triangle? And the answer to that is also no. If these a squared and b squared don't equal to c squared, then it's not a right triangle. And that's what we're trying to see. We're not trying to see if it's a triangle, just if it's a right triangle. Okay. So we're going to go ahead and see this. What if we're actually given a triangle itself? So once again, I'm going to start by finding my right angle and highlighting my hypotenuse since they give us the three sides. We've got 7, 24, 25. My right angle is right here. That's where the two legs come together. And I have my 90-degree angle, which means this is my hypotenuse. Another way I could tell that's my hypotenuse is that it's the longest side. Okay. So I'm going to go ahead and substitute these numbers into the theorem and see if it is in fact a right triangle or not. So 49 and then 24 squared is 576. Sorry, yep, the 576 equals to 625. So if I had 49 and 576, that does work. So that means triangle XYZ is a right triangle. So when the sum of the squares of these legs or smaller sides equals the square of the largest side, then it's a right triangle. If it doesn't work like in our previous example, then it's not. This next one's very similar to the try it we did, so I'm going to go ahead and flip over. We can also use this for shapes that aren't exactly right triangles, but we can create right triangles from them. So it says Ray drew the isosceles triangle LMN and the segment LP. How can Ray tell whether the segment drawn is the height of the triangle? So basically he wants to know, is 3.5 the height of this triangle, given that we have 1.3 and 3.7 here, okay? So we're going to use the converse to double check to see if these three lengths work together. So here's my right angle. It's the 90-degree angle. Therefore, 3.7 is my hypotenuse, and I can also tell that because 3.7 is the largest number. So I'm going to go ahead and substitute in the numbers. So it doesn't really matter for my legs. All right. Now these numbers are a little bit larger, so I'm gonna go ahead, well, our numbers I work with regularly, so I'm gonna go ahead and grab a calculator quick. So 1.3 times 1.3 is 1.69 plus 3.5 times 3.5, or yeah, so that's 12.25, and then 3.7 times 3.7 is 13.69. Okay. So now I need to check. Whoops, sorry, turn off my calculator. All right, if I do 1.69 plus 12.25, that gives me 13.94. So that does not equal 13.69. So what does that mean? What that means is that 3.5 can't be the height of this triangle because these three numbers don't work together to form a right triangle. So segment LP is not the height of the isosceles triangle. So once again, when we're looking at triangles like this, we're going from the top to the base, okay? So remember, the corresponding base and height of a triangle are perpendicular. So that means they form like a T, or forms a 90-degree angle. So that would be this line segment here. So could these form a triangle? Sure, but it's not going to form this right triangle here, meaning that that isn't the actual height of this triangle. We're not trying to figure out what the height is. We're just trying to determine if it's the height or not. And we did that, okay? So there is an IXL for you to work on. If you have any questions, let me know, and I will chat with you soon.